And so the calculations have been done for H2O. There's 2 hydrogens, each have 1 valence electron, so in total there are 2 valence electrons on each hydrogen. Oxygen has 6 valence electrons, so in total the molecule should have 8 valence electrons. So now we are going to create the Lewis structure. However, in order to determine the central atom, we see that the central atom is usually the first element written in the chemical formula. However, hydrogen is the exception. Since hydrogen is the exception when it comes to determining which element is the central atom, this means that hydrogen is not the central atom. Why? Because hydrogen can only form 1 bond, and although it is written first, just like many other central atoms, hydrogen will not be in the center for the reasons given. Now I will create my Lewis structure. So there are 2 hydrogens, there's 1 oxygen. Since hydrogen is not the central atom, oxygen is going to be the central atom. Now I will create the Lewis structure, Lewis dot symbol, for each of the elements and atoms written. And I'm going to strategically place the unpaired electrons in the same direction as as the hydrogens, because I know that unpaired electrons will bond with unpaired electrons. As a result, I've just placed the unpaired electrons in the given locations. And this is okay to do because electrons are constantly moving throughout the bond. This Lewis structure is just a representation of a moment in time in a molecule, so that we have an idea of what is going on within the molecule. So now I'm rewriting my structure, my Lewis structure. And here in this Lewis structure, there are 2 valence electrons for each hydrogen. So each hydrogen has its octet filled, and then oxygen has 2, 4, 6, 8 valence electrons. So oxygen has a filled octet. In addition, when we look at our calculations, the entire molecule should have 8 valence electrons. And looking here, the entire molecule has 8 valence electrons. So we know that we have the correct Lewis structure. Now, in order to determine the VSEPR geometric shape, we are going to look at our VSEPR reference table. And in this VSEPR reference table, we are going to see that based on our molecule, there are 2 bonded sides and 2 unbonded sides. As a result, we will look for the 2's in this region, right, the first column. And then we're going to look for 2 on the second column. So we see here that there's 2 and 2, and that's what we're looking for. 2 sides with bonding electrons and 2 sides with unbonded pairs. 2 and 2. Now we see that our VSEPR shape is bent. So our geometric shape is a bent structure. As a result, we can label H2O as bent.